Hello everybody and welcome back. We're looking in this video at question number 7 on our 2019 Manitoba Math Contest. A convex polygon with n sides has an inscribed circle of radius r. And they've sort of shown us a 5-sided figure example. And we've got side lengths A1, A2, all the way up to AN. Just because they show us the 5-sided one doesn't mean we can't consider bigger ones with n sides. And they're telling us the particular order. Looks like they're going counterclockwise. Okay. So we got two parts here. A part, suppose n is equal to 5, so exactly the case they're showing. Nice handy diagram there. And the sides of lengths A1 and A5 are perpendicular as shown. It would have been nice to put a little right angle there, but that's okay. Find an expression for r in terms of A1, A2, A3. So find the in radius, this tends to be called, this little r, the radius of the inscribed circle. So find in radius A1, A2, A3, A4, and A5. Okay, interesting. B part looks like it's involving the same setup, although it's talking about an even n. And we want to prove that the alternating sum, so if you add and subtract alternatingly the sides as you go around, it should be 0. That's going to be interesting as well. I don't know, yeah, B doesn't really help us work with A. Sometimes that happens on contests. As you move down a written question, the concept gets explored in more detail and more abstractly, but no, solving B isn't going to help us because 5 is odd. Okay, I really like the picture that they've added here. Let's see if we can play around with it. Now, the right angle here, I think, is probably going to be very important. That's a good enough triangle. Or not triangle, circle. Oh, I'm off today. There we go. And we'll just pretend that meets there. Okay, now because the circle's inscribed, I'm very interested in these points of tangency here. I'm going to connect things up. You can always connect the radii to points of tangency. In fact, that's something I do instinctively, because if you are tangent to a circle and you connect the radius up, you get some right angles. So along with this right angle here, we can actually see that this is going to have to be a right angle. We'll mention that in a moment. We get a bunch of right angles here. Not only that, but if we know our circle geometry, if you pick a point outside and you drop to the two tangent points, you actually get the identical length. So what we can say is this length is the same as this length. I'm going to color code them actually. This length, same as this length. This length, same as this length. This one up here, same as this one up here, and they'll have to both be r. This one here and this one here. And if you had colors, you're more than welcome to color code these sorts of things. Okay. I can't remember if this is called point tangent theorem, but we can definitely say by connecting tangent points, we see the perpendicular lines and equal lengths as shown. And this might actually be a good approach for our B part as well. If you wanted to, I guess you could name things like, tangent point 1 is on A1, then T2, T3, T4, T5. It's entirely up to you how much detail. Maybe call the center O. And they didn't give us names for the points on the... No, they didn't. But you could name them as well. A1, A2, A3. Especially if you're going to refer to them, it's very nice to be clear. So you could say, we see in our diagram A1, T1, O, T5 is a square. Now, so I've got this R here and this R here, all well and good. We should probably point that out. So AT1 is A1 T1 is T5 A1, and they're all equal to R. Now I can see A1, A2, A3, A4, A5. So those are R's. I'm going to maybe call this B1, B1, this B2, B2, B3, B3, B4, B4. So this is B1 plus R. This is B1 plus B2. This is B2 plus B3. A4, B3 plus B4. And A5, that length is B4 plus R. Okay. So because of that right angle, we got these R's here. Now there should be a way to combine these to leave the R's out. So if I did A1, I've got R. Great, that's what I want to calculate. But I've got a B1. So let's get rid of a B1 by subtracting off A2. But now I've subtracted off an extra B2. We've got to add in the A3 there to add the B2, but that also adds in a B3, so we'll subtract A4 to get rid of that B3. But then you subtract off a B4, so we have to add in an A5. And so when all is said and done, you'll get this R is left over, and you'll also get this R is left over. 2 R's have been added in. And so we have a nice little expression. Sort of the alternating sum, which is kind of what they're asking about in the next part. But there we go, we get a nice little expression for R that I have just run through. There we go, nice little box around it. Okay, so there we go with R, but you wouldn't be able to get that unless you were sure that one of the angles was right angle. Otherwise, we wouldn't get this square here, and we'd have a bit of a problem. But I think we can do something similar for our square here, or not for our square, for our circle here being bound by this n-gon. I'm only going to draw part of it. And I think it's important to be clear. So I'm going to call this A1, A2, A3. Down here would be A4. All the way up to, this is going to be AN, so this would be AN minus 1. I'm going to call my points of tangency T1, T2, T3, T4. Or no, this will be Tn. This will be Tn minus 1. Call the center O. We get all these little R's. Although we don't need the R's, I don't think, because they're not really asking us for that sort of a thing. We get right angles here. I don't think the right angles are going to be useful in what we do in a moment anyway, but I'll add them in. And you should say something like label the n-gon as shown. Okay. Now, I genuinely can't remember the name. I think it's point tangent theorem. I learned them all at one point, but I don't use them enough with their names to know. But I do know that this length and this length are the same. So what you can say is by whatever this theorem is called, and you could say point tangents to circle length are equal or something like that. You can just describe what it is. But what we can do is we can see, okay, T1 to A2 is the same as A2 to T1. T2 to A3 is the same as A3 to T3. And so on. And so we can give these numerical values. I'm gonna say something like Ti to Ai plus 1 is the same length as Ai plus 1 to the next piece of Ti plus 1. And you might also want to say SO4 all I, and then Tn is to a, or Tn minus 1 is to An, as An is to Tn. No, that's not enough. Tn is to 1. Tn goes to A1 is A1 to T1. There we go. And that would be this one here is this length here. Okay. So I'm going to say something like let Ti AI plus 1 equal, I don't know, let's call it Bi, and then Ti plus 1. Yeah. And then so Tn A1, I'm going to call Bn. No, B1. I'm numbering them by the T's. This is so confusing. Okay, so B1, B1, B2, B2, B3, B3, and so on. Okay, so we see A1 minus A2 plus A3 minus A4 plus, and it'll be plus An minus 1 and minus An. Why minus? Well, we know n is even, so it's going to alternate. All the even ones have minus signs in front of them. But that's B1 plus B2. But then you're subtracting off a B2 plus B3. And then you're adding on a B3 as well as a B4. But then you're subtracting off the B4 as well as a B5. Bn minus 1 Bn minus Bn plus B1. So now we can see, but when you do that, the B2s cancel, and the B3s cancel, and the B4s cancel, and the B5s cancel, and then the Bn's cancel, and then finally this B1 that's subtracted, and this B1 at the front cancel. So there we go. So we use that nice little circle geometry theorem, whose name escapes me. Somebody in the comments, please tell me what it's called. But because these lengths are all equal, they just sort of cancel each other out as you alternate the sum. But this really only works with even numbers. With odd numbers, it would break down. You get some extra copies of one of them, I think. Because, I mean, we get extra sort of copies of R here, depending on what alternating sum you do. It just so happened with the right angle in part A, everything worked out fine. All right. So that was, what, question 6? Question 7. There we go. Up next, question number 8. Feel free to join me for that in the following video. Take care and have a wonderful day.